All right, let's get started. So this evening we have one of our favorites. I know she's one of your favorites, Jennifer Bay Williams. She is a professor of math education at University of Louisville. She is a renowned author. She's an expert on effective mathematics teaching and learning, and she's just a great person as well. This evening, she is going to share her expertise on using virtual tools for explicit strategy instruction. And so, with that, Jennifer, I am going to get out of your way and let you do your thing and let you get started. So, thanks so much.
Thank you, Mark. That's a great introduction. Thank you so much. I am going to share my screen here. Give me a moment. All right, I think you're seeing the same slide you just saw with Mark. Is that the case?
Yes.
Yes.
Thank you. All right. This should actually say Jennifer Bay Williams and Kara and Jeff and Mark from Brainingcamp because they have really helped me to think through this session so that we can really get into the tools that Brainingcamp has to offer. So I'm super grateful for that, which means instead of having my usual like 80 slides, I have like 10 slides. And then we're going to be on Brainingcamp seeing how to use tools to build addition fluency. But I do want to start with, this is our agenda. What does it mean to have fluency with addition to make sure we're all on the same page? For those familiar names I see attending, thank you for being here. You've heard this from me before, so just one more run through of that. And then I want to focus specifically on addition and see how we can develop that with counters and then with cubes, and then some mention of some other ways that we can build addition fluency at the end. So to begin with, what does it mean to have fluency with addition? We're going to do some math. So I have 3 problems up here. Solve at least 2 of them any way you choose. That may have not been enough time, but we just have an hour together. So I want to make sure that we have time to really be on the different sites exploring the tools. So I'm going to keep going. And I would like to just connect these problems, whole numbers, decimals, and fractions with a few ideas to get us started. So procedural fluency is not just being able to use a standard algorithm, it is being able to use a standard algorithm or any set of algorithms and strategies, and importantly, know when to choose each strategy. So the components of fluency that are defined by the National Research Council and NCTM and other researchers include efficiency, flexibility, and accuracy, all 3 components. And then down below are these like look fors, these things that you can actually see when a person is fluent. What does it look like? Well, they match a problem with an appropriate strategy. So let's look at 48 plus 49. I would suggest that the algorithm is not an appropriate strategy here because it's far more efficient to just think of both of those numbers as 50 and then adjust your answer by subtracting 3, or move 1 over to make a 50, or move 2 over to change the 48 to a 50. But there's both of those methods of making a 50 or compensation are fewer steps and require less time than the standard algorithm. Thus, they're more efficient, and that's what a fluent person would do, is look for the most efficient strategy. So the same would be true with 1 and 9/10 plus 2 and 4/10, and then also the fraction problem. But I'm going to leave those for later because we're going to be tooling around and we're going to come back to these problems, and I'm going to put you to the task of thinking about the strategies you've explored when you see these problems again later. All right. So, what does procedural fluency mean? It's really all procedures. And that includes like comparing fractions, solving equations, all of those things. Tonight, we're focusing on addition. So we're going to start with basic fact addition, the addition facts, and then we're going to grow out to whole numbers and fractions. That's the blue category. So that's the piece of the big picture of fluency that we're going to explore. And even saying that we're just doing addition, we're still only scraping the surface of really developing fluency with addition. All right, so we're ready to zoom in on basic facts. So with basic facts, we have had a tradition in math of counting and then having students memorize. And that has never worked well for us. Not only do students easily forget, but we miss the opportunity to actually support their number sense growth. There is an enormous amount of research that a more effective process includes a strong focus on this phase two deriving facts. So for example, for 7 plus 9, a counting strategy would be counting on from 7 or counting on from 9. It goes back even earlier than that, counting objects. And a deriving strategy might be near doubles. A student knows 7 plus 7, and then they add 2 more. Could be that they notice the 9 is close to 10. And so they use that information to move 1 over from the 7, a making 10 strategy, or that they just know 10 plus 7 is 17. So then they adjust not to 9 plus 7 being 16. That's a compensation or pretend to 10. So I've just shared with you the 3 possible ways to solve 9 plus 7, not the only ways, but that are these 3 strategies: near doubles, making 10, and pretend to 10. Those are the strategies. It is not enough to just say those strategies the way I'm saying them to you. They need to be developed through making sense of them. So that's what our focus will be in a few minutes. Okay, from the basic facts. So again, we developed these strategies. We've invested in developing these strategies with basic facts, even though that's harder to do and takes more time. And now we have set students up for success for fluency beyond the basic facts. So that takes us to the strategies that we can do with addition to support 2 digits, 3 digits, etc. So if you look at this chart, this is from my Figuring Out Fluency book, and you can see that count on is an addition strategy, make tens, use partial sums, and then compensation. Tonight, we are going to work on one of those, the make tens strategy. It's very useful, and it takes advantage of students' place value understandings, and then, of course, the properties. So that is the big picture. We've covered it. We are ready to start exploring. So the thing with fluency is we are going to teach students to use strategies, and then we teach them to choose strategies. So remember, efficiency is about choosing an appropriate strategy. Well, in order to do that, students have to have an understanding of what their options are. They need a menu so that they know what to choose from. So we're going to first start with developing that menu. And that is when we talk about strategy instruction, explicit strategy instruction. So I want to be clear when I say explicit strategy instruction that we're talking about this definition. So I'm just going to unpack this for a moment. First of all, explicit means fully revealed or expressed without vagueness, implication, or ambiguity, straight from the dictionary. Explicit. So when we just say something to students or give them a set of steps, that is not usually without vagueness. It usually is without comprehension and ambiguous. So what we want to do to make relationships explicit is to use visuals and contexts to reveal mathematical relationships that illustrate how and why strategies work. So that's what our goal is to help students make sense of and understand the strategies through stories and visuals. So this is my visual. When I do like full day workshops, we work on teaching strategies, practicing through games and routines and things like that. And then how do we make sure we're assessing more than just answers? How do we assess students' flexibility and their efficiency? Today, we're focusing specifically on visuals, specifically on the making 10 strategy, so we can really dig into how that plays out. So here we go. We're going to do making 10. That's the strategy we're going to work on. And we're going to begin with two explorations in Brainingcamp with the Make 10 strategy. We're going to start with showing how we can work on making 10, the basic facts strategy, grow it out to whole numbers, and then extend it to fractions. So we are ready for a for our first code.
And Jennifer, I just put it in the chat in case people would like to follow along at home.
Perfect. All right. So I am going to head into Brainingcamp. So here we are with the first share code. And Jeff, you'll correct me if I end up on the wrong code. This is the one I think we're all on.
Nope,
All
you're
right.
good.
Okay. So please play along. So here's again a story and a visual to help make sense of the strategy. So your sister has a container with 9 crowns in it. So we can model that by just dragging these guys over. There's the container. She also got a new box of 8 crowns to add to her container. So we come over here and she's adding 8 crowns, which we can add however we fill it this way. Also, by the way, you can fill it that way. It doesn't really matter. How many crowns are now in her crayon box? So the making 10 strategy allows us when we see the visuals and we have the story, we're thinking, well, we could put 1 crown from her new box into the container and we can then make a 10. So we can physically make that 10 this way. Another thing that we can do is I'm going to try to do this. I need lots of practice still. I can turn them yellow. And so then what happens is students, when one student is explaining their thinking or you're illustrating their thinking, you can sort of see the old crown box, or the crowns that you previously owned, the new box that you bought, and the ones that have moved over. So when you do it in 2 colors, you can see the before and the after a little bit better. All right. So that is an example of stories that with visuals to help build this making 10, filling 10 frames. That strategy grows. So we can grow that strategy, and I'm having some trouble sliding over here, Jeff, to my new problem.
So I think you're slid over as far as you could, but you could hit the zoom button in the bottom left-hand corner of the Brainingcamp screen. Yep, the bottom left,
Bottom left, my
where you see
workspace.
the little hand lens with the plus sign. Just
Okay, let me move.
bottom.
I got the chat kind of blocking me.
Oh, gotcha.
All right. Okay. So I see
There you
Zoom.
go. Yep.
All
And if
right.
you hit it a couple more times, you'll be able to zoom in a little bit further. There you
But
go.
but I'm trying to get it over to the 49 plus 47.
Oh, we can see it on the screen.
Oh, you can. Oh, it's just me that can't. Oh, I see. I just need to slide my whole screen over.
There you go.
All right. So here we have grown it out. So in this case, I'm using color to show full 10 frames and partially filled 10 frames. And this is very much like the problem that you already saw abstractly. And you can see how you can move a counter up. And you can also do the color thing again, where now the frame is full, so you can color it. I'm working on this. Whoops. Sorry, my problem is I got to scoot my screen over more. All right, here we go. Let me try again. So once I can grab all the counters, then I can turn them red to show that I have filled a frame. Now I can see in red all of my tens. Very cool. I've got 9 tens, and then I can see my ones. So we can show making 10 in color, and you don't even have to worry about the color. You can do one color, and the students can click and drag to show they're making tens. So the 10 frames work beautifully for showing make a 10 because, of course, they're 10 frames. So they help students to see how they can do that. All right, I think we are ready for our growing to fractions, which is our, or are we going to a new story? Let me look.
I just put the fraction egg question in the chat as well. Yep.
It's time to grow to fractions. We're growing very quickly. This is our vertical alignment across the curriculum with the same tool. So here we go. We are going to work on filling cartons. So one of the important things with fraction instruction is to make sure you identify the whole. So notice on the screen that you can see here, we have a full egg carton, and that is one whole carton with its 12 eggs. All right, then we have something going on here. So again, we're pairing the story and the visual. So here we go. Two friends, Annie and Noah, have gathered eggs from the hen house. When they come inside, they combine their eggs to get as many full egg cartons as possible so they can sell them. How many full egg cartons and what fraction of an egg carton is filled each day? So let's see, day one, and you have this code, so feel free to do this. You don't have to watch me do it, just dig in. Annie's eggs, we'll do red for Annie's, it doesn't really matter. She has a full egg carton, and then she has 5/12 of another. And Noah has 8/12. There's the 8/12. And if you want to show this in different ways, again, you can fill it different ways. And so the question is, how do we fill the egg cartons? So one possibility here, as the children are thinking about this, I usually engage students or teachers and ask, what do you think is going to happen when they come inside? And usually the answer I get is, well, it looks like Annie will, Noah's kind of close to filling an egg carton, so Annie will probably give him some of hers. So then, of course, skip counting by fractions is important, just like skip counting by whole numbers. So we can count over, there's 1/12, 2/12, 3/12, 4/12. So now I have filled this egg carton. So now I have 1 and 1/12 plus 1. By moving 4/12 over, I have changed this problem. So if you look at on Monday, I've just reasoned about Monday. With students, they can rewrite the expression. So the first expression is 1 and 5/12 plus 8/12. And the rewritten expression is 1 and 1/12 plus 1. Or they could say 12/12 if they wanted to, but it's 1. And then they can calculate the total sum, which is 2 and 1/12. So then they can fill it in the total. So I want to give you a moment to use the counters and to model Tuesday. So I'm going to pause, and then I'll also do some clicking and dragging. All right, just for fun, I'll skip to Friday. For Friday, Annie's got 1 and 1/12. So we just fill her frame. And she's got 1/12 more over here, put it in the carton. And Noah's got 1 and 11/12. So we come down here, and just to model how it doesn't really matter, you can use red here, fill up his first carton, and put that one in the carton, and it's all but one full. And this is a nice visual to see that you can move a 12th over, and now we have 3 full egg cartons. So we're able to show this really well. A question you might have is, well, these are 12ths. That's not where I start with my fraction work. Correct. So what you can do is when you're designing a new task here is, let me just give myself some space here, is when you upload these frames, let's see, sorry, I also have my Zoom stuff blocking some of my visibility here. Okay, so we bring this frame up and you can make it any size. So let's say you wanted to have a similar fill the egg carton, but you're just using, little eggs, the cut off egg cartons. So then you could have your egg carton be this size, and then they're just filling up these little cartons. Maybe they're just selling them to, in small bits, especially because the price of eggs have gone up. You can keep these numbers here. If you click on them, you can turn the labels off. And so you can do the same problem with fourths, and you can change the context. I like this context because it makes sense that you'd want to fill one of the objects. And if we wanted to change the size to 6, that's another, of course, half egg cartons are very common. So it makes sense to do 6, so we can change the shape of the egg cartons. All right, so this is one tool, the counters and the array frames that we have used to work on the making 10 strategy, starting with basic facts, moving to whole numbers, and then seeing what a beautiful model it is for fractions. All right, I'm going to turn it over to Jeff to, Jeff, is it your turn?
Yes, it is.
Jeff's going to show you another tool that is similar. And actually, we're going to come back and have you talk in the chat about how they compare. So Jeff's going to talk about the Rec and Rec.
Awesome. If you go ahead and stop sharing your screen, I'll go ahead and share mine. All right, so like Jennifer said, I am going to model that same process we were doing of making 10. However, this time I am going to be using the Rec and Recs. And I know Rec and Recs are an awesome strategy we can use for modeling numbers, for addition, for subtraction. So I just put in the chat this share code. And I know we keep spitting all these different share codes at you. Like Jennifer said, if you'd like to participate in any of these share codes at home, that's why we're putting them in there. If you like any of these share codes and would like to use them in your classroom, of course you can as well. So the question that you can see on my screen says that Nolan had 9 cars, Jonah had 6 cars. How many cars? So what I'm going to do is I'm going to actually turn on the group labels. And in this first Rec and Rec on top, I'm going to go ahead and build my 9 and build my 6. Now, of course, we all know what the answer is already, but remember, we're pretending that we're working with young students. And the whole purpose of today's lesson is making 10. So I'm going to do the same exact thing to my Rec and Rec on the bottom, where we can see that we have built 9 and we've built 6. And because we're trying to make 10, what I realize is I can get rid of one of these off the 6 and add that on to the 9. And there we can see that 9 plus 6 is equivalent to 10 plus 5. And another small feature that we just recently added in the last few months is this button here where you see rack labels. That's kind of a cool feature that we just added so that the kids can actually see 9 plus 6 on top is 15 in addition to 10 plus 5. Now, in case you're working with older students, second, third graders, and you're adding much, much larger numbers, within the same share code, if I just scroll over to the right, I have a little bit more challenging question. And what I'm going to do here is I'm going to turn the rack labels off because there's a special feature that I want to show you here in a minute. So same type of question, Nolan had 38 cars, Jonah had 17. How many altogether? Well, let's go ahead and let's build 38. Just like you can see there. We'll build 17, of course 10, and 7 more. Now, hopefully you guys' wheels are spinning already how we can use that same strategy of making 10 on this question. Of course, I can't hear you. But what I'm thinking, when I look at the 7, I know that I could get rid of these 2 here and add them to my 38. So now we can see that, 38 plus 17 is equivalent to 40 plus 15. Now, I showed you the super cool rack labels feature earlier. If I grab this Rec and Rec on the bottom and select it and drag it together, now you can see that it magically goes to 55. So we just wanted to model another way that we can make 10 using the Rec and Recs. And I know there's a lot of teachers out there that probably have not discovered those rack labels. Super, super powerful tool that you can use with your students. All right, I'm going to go ahead and turn it back over to Jennifer.
All righty, I'm sharing my screen, and we are just gonna take a moment back over with my PowerPoint. I just want to pause because you saw two tools that have some similarities and have some differences. So if you would just take a moment to reflect on the two color counters and the rec and recs in terms of developing this strategy, what do you notice? And you can just enter that in the chat. Christina's noted this one doesn't grow to fractions. I agree with that. Although as soon as I say that, somebody's gonna be like, "Wait a minute, we could do it this way." But that's right, because with the arrays, you have so much flexibility and not just growing to fractions, but also what fraction partitions you're working with. There's a question here that I think is so important. Will students get confused if we use more than one tool? I think it's through multiple representations that these ideas for students really solidify. But I think it's a really good question about how soon, when is the time to introduce a new tool for investigation? So I certainly wouldn't do it like I'm doing it with you all, like, oh, look, here's one tool and let's move over to the other one same day. I would definitely, give some time to explore the one and then go to the other. So one of the things you might have noticed when you were watching Jeff is with the two color counters, it's a physical, like you really are moving a counter over and making a 10. With the rec and rec, you're doing a trade. So that's a really nice thing, again, to build for this whole idea of trading that we do with our ones and tens later on. So it's nice to do that. As I was watching him, I was noticing he knew that 7 was 5 and 2. That's why he was able to just click and drag those over. So that's a really nice opportunity in working with the rec and rec for students to see that 7 is 5 and 2 more, that 8 is 5 and 3 more. So there's just different insights that you gain from using the different tools. But definitely too many tools can be confusing if they happen too fast. All right. And as I was saying that, I'm missing other comments. Is there anything else, Mark or Jeff, that you think I should highlight? Are we ready to go on to the next tool?
I think we're ready. The only thing I see is that some few folks mention they use rec and recs for multiplication.
Oh, nice.
Very
Right,
cool.
because you see the equal rows. Beautiful. All right, so both of these tools showcase 5s and 10s. So great for developing that number sense of, where numbers lie between 5 and 10, and then between 20 and 30, and that sort of thing. So really good for that. We're going to move from using counters to using cubes. And so here we go. We are going to go to the linking cubes, and we're going to be making 10s. Of course, you can pick the colors to still do 5s and 10s. If you want to do color patterns, you can. And this time we're going to go making 10 to make 10s. This says make a whole with fractions, but I lied. It's actually decimals. I have to fix that slide. That's what we're going to work on. All right. So we are ready for the next code.
All right, I just put it in the chat.
All right. Does it look like what I have up here, Jeff?
That is correct.
This is good news. All right. So here we have a new story, which, by the way, these stories are interchangeable with the tools that we're using. So Leah set a personal goal to exercise at least 20 minutes a day. 10 minutes before school and 10 minutes after school. On Monday, she exercised 8 minutes. Before school and 14 minutes after school. Did she meet her goal for the day? We'll do after school in red. Move that over to that Rec and Rec. And so in this case, you could choose to use the tool or just the story, by the way, because this one doesn't even ask for an exact answer. It's just saying, does she meet her goal for the day? And then I say to students, how do you know? Prove it to me or show it to me. So this is just a visualization of how they might demonstrate their understanding. So this is the 8 plus the 14, and they can say, well, you could take 2 of those afternoon minutes and move it over to the morning. And then you see, whoops, I've lost a minute. Well, that happens to me way too often. If only I could gain a few minutes back every day. So there's a visualization that you have those extra 4 minutes in the afternoon, you move 2 over. So it's a nice just kind of entree into solving problems with exact answers. All right. Sorry. I think
The next one you have is the mango question.
Is the next, it's a next link.
It's in that tab right there. You go.
Okay. So here we go. So this is another one of my favorite stories. There are 8 mangoes in a bowl. There are 6 mangoes on the table. How many mangoes? And so if you just picture this for a moment, picture mangoes in a bowl, or it could be oranges, or perhaps those of you that live in other parts of the world could share a very common fruit that children enjoy eating. Feel free to enter that in the chat for the rest of us to benefit from. But you can picture these bowls, and with these multi-link cubes, or sorry, unifix, linkets, we can model it on a number path. So here are 8 in the bowl, and then we have mangoes on the table. Well, there's a couple of ways we could show this. So one is just mangoes on the table. Let's have them be yellow. They're the ripe ones. Super ripe. So here's these ones on the table, and they can just be disorganized. You know, they're on the table, and then students can see that they could put 2 more in the bowl, and then they have 10 in their bowl, 4 on the table. So so it lends to making 10. We could also hide these numbers so they don't show through. I like them showing through. And we can do this, duplicate this whole number path so that there's a number path for both. So I just think for this context of the bowl and the table, this is a nice way to visualize it. You could choose to have these lined up. It really doesn't matter. I think, again, just being able to see that the tool is there to support your thinking and not have too many, like worries about exactly how those visuals are there, as long as they're highlighting the concept. I saw somebody mention that in the chat. Some manipulatives can obscure the idea. We're looking at ways to highlight the strategy of making 10. All right, that's the mango problem, or any other story. And we're seeing how the linked cubes can be used to make a 10. All right. That's our basic facts. And now we're going to grow it to a whole number example. With the linkets, you can see that you can just do a stack, and you can keep copying that stack over pretty readily. It's pretty easy to just grab a stack and then just copy it and have another stack. So in terms of creating these problems, they're pretty easy to create. So here's our original problem. And so my question to you, and you can enter it in the chat, is what is the expression? What expression do you see represented here in the 2 colors? Okay, I'm seeing a lot of 38 plus 27, and I'm seeing a few that have shifted it over by moving the tens around. So by color, if you're going by color, you have the 38 plus the 27. How many cubes? And so we can, the students can move the cubes around to do to figure it out. And they can, right. And I'm seeing somebody just typed in a partial sum. So this is a beautiful crossover tool where the students might see, oh, I've got 5 tens, and then they have their ones. And then you're really doing this sort of making tens thing here. Whoops. I only need 2 of those. It wants to grab 3. I'm just going to move them one by one. So you can do a partial sum strategy here, or you can do the making 10. So now you see you have 65 by doing by pulling them over. And so that's the whole number. And let's just slide this over to now reinterpret the cube as 1/10 of a unit. So if we rethink this problem with this being 1/10, what is the expression now? Right, we have 3 wholes because we have 10 tenths. 10 tenths is 1 whole. And I'm jumping way ahead, right? We need to do a lot more thinking about our tenths, counting them as we build them. 1/10, 2/10, 3/10, 4/10. We have 10 tenths, that's 1 whole. But we have 3 wholes and 8 tenths. And then we have 2 more wholes and 7 tenths. And so we are now moving from make tens to the make a whole strategy. So I can move these 2 over. See, now they're cooperating. These 2 over, and I have made a whole. So now I have 6 wholes and 5 tenths, 6 and 5 tenths. And that's a strategy that is, I think when, we need to be better about strategies in general, but we're doing some strategy work with whole numbers. In the US, that's been called out specifically in the standards. But when we get to decimals and fractions, we kind of forget about using our place value ideas and this whole idea of make a 10. And this idea really helps students with one of the things they're most confused about with fractions and with decimals, which is you're working within wholes. You're in between wholes when you have decimals or fractional values. So this supports their understanding while also offering a really nice reasoning strategy that's more efficient oftentimes than an algorithm with regrouping. Beautiful. All right. Let's see. I'm just going to go to this one very quickly, and then I'm going to go back to my slides. We have, this is just a little glimpse of one more tool. So we have seen the counters, the 2 color counters. We have seen the Reconrex, the cubes, and then, and all of those are length / count quantity models, right? So you saw the counters, and then the cubes can be counting set model. There also can be a length model. So I wanted to showcase this strategy with an area model. So this is, we're back to fractions. And here we have 3 3/4 plus 7/8. And this is fraction circles. And if you think about a context, think about a pizza party, and the party is over, and this is what's left over. And so you're thinking about filling up boxes of full pizzas. And so you can move these over to make a whole. This guy needs some help. There we go. So we've made a whole pizza, and then we have this opportunity to make a whole. And so we can look at that then numerically and see how we could move 2 of the eighths over to make a whole. And then we have the expression 4 plus 5/8. And that is a much easier problem to add. And actually is a strategy that I have used with students that have dyslexia, that are at a special school, and I've done it with students with special needs. This strategy of being able to make a whole makes a whole lot more sense. And so they're like, well, does this always work? When can I use this? And the visuals allow me to be able to say to them, you just showed me that it works. You just moved those pieces of pizza over. Is that the same amount? And so it gives them time to really think about that. In fact, when I was working at the school with children with dyslexia, we did both the egg carton example and the pizza example on 2 different days, talking about mixing the different visuals. And then in the end, I asked them, when will you want to use this idea of make a whole versus the, algorithm that you already learned? Because that was the other thing. They already knew the algorithm. And they thought they would use this strategy when they were doing math for real life. But for homework, they might go ahead and still use the algorithm they were taught. So I thought that was a very compelling explanation for, or powerful thing about this strategy, is it makes more sense. They'll use it in real life. All right. So I'm just going to go back to reflecting on this. What insights have you gained related to using tools? It could be the linking cubes, or it could be any of the other ones that we've seen tonight, but using tools to support addition fluency. And I'm going to say a few more words, and then Mark, Jeff, I'm going to have you come back with any of these questions that are asked. If you could just say them to me so I'm not missing them, then we'll have some opportunity for Q&A.
That was good.
All right, so I wanted to come, so we have looked at, it says exploring addition strategies. We've explored one strategy, making tens with counters, and then one strategy with cubes. So I want to come back to the problems I told you that we started the session with, and just think about one of the visuals that you used tonight. So I think this is important for students too. We use the visuals and then we can use mental images of them. So pick one that really resonated with you: the counters, the rec and rec, the link it cubes, or the fraction circles. And just think about, especially the decimal and the fraction one. It might be your first time to think about those problems using a make a whole strategy. So I'm going to be quiet for a moment. So if you didn't solve it this way earlier, I hope you have thought about how you can easily move a tenth over, and what a beautiful strategy that is for students. And here you can move an eighth over, or you could move a half the other way. You can always go either way, of course, but usually students are going to the one that's closest to being the next whole to move some over. So revisiting some key points from the night, we teach students to use strategies, and then we teach them to choose. So again, tonight, we just worked on using one strategy, but imagine that we had more time and we left make tens and we started working on a few others. We can use some of those same tools. You saw in the chat that people were using partial sums with the linking cubes to just look at the wholes and then the parts. And that's a great strategy. And then we could also use compensation. That's another workshop, Mark, by the way. We just focus on compensation across the different visuals. But with compensation, they might be adding a cube in, or a bead. And then they have to remember in the end, after they add, that they're going to take it back away. So that's the compensation strategy. That's how that one's different. So once they learn to use other strategies, then you come back to choosing activities. We can do routines, games, and that sort of thing, so that we teach them to use the strategies, and then we help them to choose, making decisions and talking about when one strategy is useful and when another strategy is useful. Like, when would you pick the making 10 strategy? That's a question I love to ask students at the end of a lesson. When would you use this strategy? And this is how we build students that have positive math identities and a sense of agency. So when we have students just remember this method, remember this method, remember this method, they're just like, trying to log it all in and keep up, right? That's sort of the mentality. They don't feel empowered. They don't feel like they are the doers of math. And in fact, they're not. They're just imitating or remembering. So what we're trying to do is turn students into reasoners, not rememberers, and so that they have that agency and they can look at a problem like 2 7/8 plus 2 7/8 and just say, well, I know that I can do that in my head. I don't need to do a bunch of regrouping and all that sort of stuff that isn't necessary. So this is our goal with all of our teaching, and I wish you well with this strategy and helping your students to really develop that positive identity and mathematical agency. Thank you so much for joining.